problems. We don't have that many. 11 through 27 odd. And the section isn't that hard. Okay, 37 through 39. We'll save the difficult part for tomorrow, which is going to be hard. Okay, this is called implicit differentiation. It's a piece of cake. Okay, just have to listen to me carefully. Okay, it's not that hard if you pay attention. Number 12. Okay, they give us an equation, x to the third minus y to the third, okay, is equal to 6xy. Okay, now if you want to solve for y and then take a derivative, this is going to be hard. Okay, so simple things like this could be impossible to solve for y. So when that happens, we can still take the derivative because we're finding, okay, dy dx, okay, or y prime. Okay, that's what we're going to find. Well, we can take it as is, but we have to use what's called implicit differentiation, and which involves chain rule. Okay, we're going to take the derivative of the first term, so we're going to take the derivative of the function as is, okay, without solving for y. Then we'll solve for y prime. Okay, when you take the derivative of x to the third, that's going to be 3x squared. That's easy. Now this is where this gets tricky. We are taking the derivative of the function y, and that is y to the third. So when you take the derivative of this, you have to apply the chain rule, which is 3. We applied the chain rule here also, okay, which gave us 1 times 1 inside after the x squared, so that didn't make any difference. Here you're going to get 3y squared. That is easy. Okay, but when you take the derivative of the y, when you apply the chain rule, you don't get 1 because this is with respect to x. So therefore, you're going to get y prime. That is the chain rule. All I did was apply the chain rule to this. Because when you apply the chain rule, there's really, when you think about it, that's really 3x squared, which is the derivative of the outside, and then take the derivative of the x, which is 1. But when you apply the chain rule for this one, you're going to get that, not 1 for the y prime. Okay? And then when you go over here, 6 is just a coefficient. I'm just going to move that to the outside, so get it out of the way, put some brackets. Here's a product rule. First times the derivative of the second. When I take the derivative, every time you take the derivative of y, you have to get a y prime. Okay? Plus second, which is y, times the derivative of the first, and the derivative of x is 1. So that's done. Now all you have to do is clean it up and do your favorite thing, which is called algebra. So let's clean this up. I get 3x squared minus 3y squared y prime is equal to 6x y prime plus 6y. Now this has a y prime in it. This has a y prime in it. That means I'm going to take that to the right, and that turn to the left because I'm solving for y prime. So I'm going to get 3x squared minus 6y is equal to 6xy prime plus 3y squared y prime. Okay, what do I have to do? I have to factor out a y. We've done things like this before. Factor out a y prime, that is. When I factor out a y prime, I'm going to have a 6x left in the first term, and then what I have in the second term is 3y squared, and then I have a 3x minus 6y, and then when I solve for y prime, I just have to divide by this. So my y prime is equal to 3x minus 6y, all that over 6x plus 3y squared, and that's it. Okay, the algebra in this one wasn't that bad, but it could get bad. Let's try number 14. Okay, this is number 14. I have suspicion the algebra here is going to get ugly. So x to the third y squared minus 5x squared y plus x is equal to 1. Okay, we're going to take the derivative of this. We're finding y prime. Okay, find y prime, or dy dx is the same thing. Okay, product rule right there. We can't solve for y because it's just too hard to solve for y. So first times the derivative of the second, derivative of that, which is 2y times y prime, because I'm applying a chain rule, plus the second, y squared, times the derivative of the first, which is 3x squared. So every time you get to a y, you're going to get a y prime, minus. This 5 is just the coefficient. I'm just going to get that out of the way for right now. then I'm going to use a product rule right there. First times derivative of the second plus second times derivative of the first. Okay, so that's done. Then I have to take the derivative of that, so I'm going to get plus 1. And the derivative of 1 is 0. So I have a y. I'm going to clean this up. So I have a 2x squared y prime plus 3x squared y squared, and then I have a minus 5x squared y prime plus or minus 5, or no, 10 actually. That's 5 times 2. That's 10. Okay, minus 10. Okay, x plus 1 is equal to 0. Alright, so I have a y prime here, and I have a y prime there. That means I'm going to move this to the right, this to the right, and this to the right. And I'm going to factor out a y prime from both of these. So let's go ahead and do that. And that's going to give me negative 3x squared y squared. Moving that to the right, it's going to be plus 10x. Moving that to the right, it's going to give me minus 1. And then when I factor out y prime from here and here, okay, what's left in the brackets is 2x squared y from that. And then what's left from here is a negative 5x squared. And then when I divide, y prime turns out to be negative 3x squared y squared plus 10x minus 1. All that's going to be over 2x squared y minus 5x squared. And there it is. Okay. There it is. Alright, I guess that wasn't that bad. Okay, let's try a second derivative, which is 22. This is 22. Okay, I have x to the third plus y to the third is equal to 1, and they want me to find y double prime. Okay, so we're going to take the derivative as is. Okay, so derivative of the first term is going to be 3x squared, that's easy, plus, when I take the derivative of that, I'm going to get 3y squared times y prime. And of course the derivative of 1 is 0. Now you can stay here and take the derivative of this as is, but I wouldn't. I would want to do algebra. Every time you have to take a second or third derivative, you want to do some algebra and clean it up. So I'm going to take this to the right, and then I'm going to divide by that. So my y prime turns out to be negative 3x squared divided by 3y squared. Okay, and the 3 is going to cancel. Okay, now y prime turns out to be negative x squared over y squared. Okay, when I take a second derivative, my negative's on the outside, but this is a quotient, so I have to use a quotient rule. So denominator, which is y squared, times derivative of the numerator, which is 2x, minus the numerator, which is x squared, times derivative of the denominator, which is 2y times y prime. Okay, all that's going to be over the bottom is squared. Okay, and that's my final answer, right? Well, this is my second derivative, not first derivative, second derivative. Okay, well, almost, you just can't leave y prime. You got to write everything in terms of x and y. See this y prime right there? I have to replace that with what my y prime really stands for. So I don't have to clean it up, but I do have to replace that. So y double prime is negative. Okay, brackets. So I have a 2xy squared. Okay, minus 2x squared y times my y prime, which is negative x squared over y squared. Okay, and all that's going to be over y to the fourth. Okay, now I can stop because I can't have y primes in there. I have to go back and substitute. Okay, so I guess I'll see what else I want to do for you. Is give you 37 and 39. 37, 39, you should be able to, yeah, that's pretty easy, because they tell you what are the constants. Okay, and alright, let's do 28, so that will be the last example. 28. Okay, 27 is done this way. So I get y squared minus x plus 1, okay, is equal to 0. And then they want me to find, in this section, for these two problems, they want you to find the slope of a tangent line to the curve. Just the slope, okay? The two ways. First by solving for y, and second by doing implicit differentiation. I don't really care about solving for y. Let's just do it by implicit differentiation because that's what this section is. So we're going to find the slope using that point. We're going to find the slope using 10 negative 3, okay, for this particular problem. Okay, first of all, we're going to take the derivative of this as is, so that's going to give me 2y times y prime, and the derivative of that is negative 1, the derivative of that is 0, and there it is. Okay, if we want to find the slope, now we're going to solve for y prime, so this is 2y prime is equal to 1, and then y prime is equal to 1 over 2y. So we're going to plug in 10, 3. So y prime at 10 comma 3 is, I'm plugging in 10 for the x and 3 for the y. But there is no x right now, so I don't have to plug anything in there. So it'll be 2 times 3, which is going to give me 1 over 6. Of course, when we plug in y prime of 10, okay, minus 3, again, we don't have to plug anything for the x because we don't have any x's. So we're going to plug in negative 3 for the y, so 2 times negative 3, which is going to give me negative 1 over 6. Okay, that is it. Okay, easy section.